cross and expect to see your face, and remember you're 1,000 miles away.
Hey, Vsauce, Michael here. But what do we mean by here? Oh, we are here, but okay, let me just show you, alright? So, here we have 2 green pens and 3 blue pens, okay? So what I'm gonna do is separate these green pens over here and the blue pens to over here. Right, so what I've just done here is that I have differentiated them according to their colors. But what do we mean by differentiate? Well, first, we gotta know our limits. Limits in mathematics can be denoted by LIM, named after a famous mathematician, Doofus Smoofus Lim. Okay, moving on. So how do we calculate limits? Let's say, for example, we have an equation, which is y equals to 1 over x. Alright, and let us consider the graphical representation of this equation. Alright, so we have y-axis and x-axis. Okay, so the curve would look something like this. Okay, it doesn't really touch 0, but yeah, we'll just forget about it. Okay, let's say we have numero uno and numero uno. Okay, so let's consider taking one step to the left. So with one step to the left, we're gonna extrapolate the x value and consider the corresponding y value. So it has increased. Great. So we're gonna take another step to the left. We're gonna dot here and we're gonna find a corresponding y value, and it has increased once again. So with this, each iteration, we're gonna take one step until we are very, very close to 0, but not really 0. This is what we mean by limits. So we can express this process in terms of the limit of 1 over x as x approaches 0. So in mathematics, you can't really have x equals to 0 and 1 over 0, because 1 divided by 0 is, you're breaking math. It doesn't exist. So with this process, we can find out what the value of y tends to when x approaches 0, meaning it is very, very close to 0, but it is not 0. Understood? Okay, so with this, we're going to have a value of y that is so large, so it's going to tend to infinity. Therefore, this limit equals to infinity. Okay, moving on. So let's say we take one step to the right. So we're going to have a corresponding value that's decreased from 1. And another step to the right, it has decreased again. Another step, and we're going to keep doing this until this infinity somewhere over here, for example. Okay, so infinity is not really over here, but it's over here somewhere. Yeah, it's beyond this graph. We don't know where it is. Yes, we don't know. We physically don't know where it is. So with each iteration, as x approaches infinity, the y value should approach 0. Therefore, we can say that limit of 1 over x as x tends to infinity is equals to 0. With our new interpretation of limits, let us proceed to derivatives. Get a fresh sheet of paper because I am poor and I can't have a proper setup or a tripod to have this educational
Are you sure about that?
video out for you. Okay, nonetheless, moving on. Now that we understand the concept of limits, so let's say we want to have this y-axis and the x-axis y-x. We're just going to draw a random graph just like this. Okay, and we're going to have a secant line that passes through 2 points of this curve. Ooh la la, not very straight, just like my sexuality, just like my sexuality, just like my sexuality. And we're going to name this fx. And we're going to name this point x0. And we're going to name this point x0 plus delta h. Alright, moving on. No, not moving on. We're going to have this corresponding value of fx0 and this corresponding value of fx0 plus delta h. So let us draw another curve, but this time delta h will be smaller. Okay, so we're going to draw a curve like this. Ooh la la, amazing, so straight, just like my sexuality, just like my sexuality, just like my sexuality.
Yes, 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 yes. Yes.
Cool. We're going to have this, and the next line we're going to have this. And as delta h becomes smaller and smaller, we're going to eventually lead to the tangent line, which is here. So this means that using our understanding of limits, we're going to compute delta h such that delta h tends to 0, so that this value becomes so small that it is negligible. Okay, so what do we mean by this? So we know that the gradient of this curve, it's going to be fx0 plus delta h minus fx0 over delta h. So this is change in y over change in x. So this we know that. So over here, we're going to find the average rate of change from x0 to x0 plus delta h. And as delta h becomes so small, this means that we're not going to find average change, but we're going to find the instantaneous rate of change at x0. So we're going to denote this as dy dx equals to the limit of fx0 plus delta h minus fx0 over delta h as delta h approaches 0. And ladies and gentlemen, this is the definition of differentiation. Yay. So with differentiation, not only can we differentiate the colors of the pen, but we can use differentiation to determine the movement and the motion of the objects in the solar system, in the universe. So differentiation is in all of us because all of us move from here to here. And as always, thanks for watching.